I've got auto, stabilize, and alt hold. So now we're in stabilize. Battery looks good. So I'll go ahead and arm up.
It looks a bit like a spider on steroids, but it's a high-tech, precision, heavy lift tool.
All right, going hot.
It's a research tool, a flying platform packed with instruments.
Ready? Connecting. We armed?
Armed.
Yep. Going up.
Graduate student Max Messenger designed and built the drone for Wake Forest University's Center for Energy, Environment, and Sustainability.
This is a technology that's matured over the past, 10 or so years as parts, the sort of critical parts to it have matured. So there's things that detect rotation, gyroscopes and accelerometers that can detect movement, and they detect gravity. And those are all the sensors that allow this thing to be stabilized. Yeah, I want to see what my flight modes are.
And here's what a drone can achieve.
And you can see the ash that was left.
This is Duke Energy's coal ash pond that spilled into the Dan River near Eden, North Carolina. The video clearly shows where the ash washed out after a pipe underneath the pond collapsed. The location of the water line when the break happened is also visible.
And so what we were able to do is to go in to be able to calculate how much ash and toxic water was missing from this pond after the rupture.
The drone flew in a grid-like pattern over the site, snapping roughly 250 images at regular intervals. Those images were compiled to create a 3D model of the ash pond.
Because you had the water, and we can go and reconstruct the shoreline, and then you take that as a surface and you know the bottom, and you can calculate the volume of stuff that was missing.
By comparing the new image with existing aerial photos of the pond before the spill, researchers calculated about 35 million gallons of ash and water slurry spilled from the pond into the river. It provided an independent verification of Duke Energy's estimate. Researchers shared their data with Duke Energy, federal and state regulators, and environmental groups. It was data best captured by a drone.
But there's a lot of questions where we need a much smaller resolution. So when we think about the most widely used satellite, that gives you a resolution that's about almost 90 feet on a side, if you want to think about the size of the unit that you're looking at. Well, if you're interested in flowers and tree crowns and other kinds of processes, you need to look at it at a much higher resolution. And what these robots that we have operating in 3D space allow us to do is to really look at small scale.
The Opticopter is made from carbon fiber and aluminum parts. Cost about $2,000. It takes a few days to build, several weeks to fine-tune.
This one has 6 motors. It's got computerized motor controllers, and then the kind of brains of it are right here. This is the onboard computer that has all of the sensors built into it, so it's able to detect the angle of the aircraft and make corrections to stabilize it. And so it sends all of those corrections to the motor controllers, which then speed up or slow down specific motors to keep it all stable and in the air. And then it has a GPS and compass right here, which allows it to know where in space it is and fly pre-programmed flight paths autonomously, automatically land and take off and that sort of thing.
It's all in adjusting the speed of the rotors. That's how the drone changes direction, altitude, and even achieves level flight. 2 batteries provide about 15 minutes of flight time. Top speed, about 20 miles an hour.
Control with this happens with pitch and roll. So if we want to, this is forward. So if we want to go forward, the computer, we will tell it, I want to go forward, and the computer will convert that command into speed up these motors, slow down these motors, which will tilt the aircraft forward, and then it'll hold that tilt, which causes it to move forward through the air. And likewise, the same things happen with roll. So down here is the camera mounted to a gimbal stabilizer. So this has motors and sensors to keep the camera stable.
The team has studied reef systems off the coast of Belize and forest change around Pilot Mountain. Their next drone science project will study the effect of climate change on the Amazon rainforest. The target, the western Amazon region of Madre de Dios in Peru. It's about 3,000 miles wide and home to an estimated 390 billion trees. It is a major catalyst for Earth's climate and weather patterns. The drones can fly close enough and steady enough to study leaf canopy temperature, which will help determine how much water vapor the trees will put into the atmosphere and how much carbon dioxide will be removed.
There we go.
It's really interesting. It allows us to answer a lot of problems that were intractable and to think about new areas of research. So we can do things now with these robots that we were unable to do before.